video. Matrices in MATLAB. So we've already seen matrices once or twice. I created a matrix, for example, of 1 to 100 for another problem. And this tells us a couple things about how to enter matrices in MATLAB. We've also seen a square matrix previously. So the square bracket will start up the matrix. And a colon. Now you guys can't see this window if you're following along on the video chat. You guys can't see this because it's on a separate computer. But so this might be real boring for you. It'll get up to YouTube and you guys can watch it. Okay, carrying on. Colon. The colon symbol represents, is just a symbol that lets you do a list. And then you end with a square bracket. So it goes start, step, stop. So the colon mark means, oops, I used a brush tool. I want to put down some text. So the colon tool helps you, there, set up the matrix. So vector, just a line. That's what's going on. Vector list. You're just making a vector list. A equals, start with an open bracket. Then you put the start number, colon 100. So that's just start and stop. It'll just create a vector list from 1 to 100. Now you need to use the square brackets, not curly brackets. So let's get a brush and go the first number, second number. If you've only got two numbers, one's a start and one's a stop. Okay, so the next thing you might want to do is, well, what if I want different step sizes? Say I want to step it by 5. Square bracket 1 colon 5 colon 100 square bracket. So this gives you a list counting by 5s. It'd be interesting to see what that does in MATLAB. So, but before I go to MATLAB, let's just do this. This time you have a start, a step, and a stop. Start, step. Second number is a step. Third number is a stop. And first number is the start. Second number is a step. Third number is the stop. And let's see what that looks like in MATLAB. And that's what it looks like. It starts at 1, so add 5 to 1, you get 6, and so forth. You keep going through to 96. And maybe I wanted 0 to 100 stepping by 5. Oops. Okay, that produces a list of numbers. The way to produce, so this is a row vector. There it is. I'm looking for my tools. Row vectors. So column vectors, same thing except you add an apostrophe. So this time you would say A equals bracket 1 to 100, close the bracket, apostrophe, just a single apostrophe there. And I'll cut and paste that over into MATLAB. And now we get vectors in a column list. There we go. Column list. This stuff, all this stuff right here. Instead of a row list that we had previously, the apostrophe makes it a column list. There we go. With the apostrophe. Without the apostrophe, you get a row list. First number, start. Second number, how big the step is. Third number, how what's the ending? What's the ending? Okay, so there's something else we can do. Another way to do this is what's called linspace. There's also a tool called log space. It'll give you evenly spaced on a logarithmic scale. But B equals linspace. What you have to do with linspace is enter the start and the end and the number of steps. So let's go start 0, comma, end 100, comma, and number of steps. Now we're going to see a problem with this as soon as we do it. And that's these weird, it's not evenly spaced intervals. We got to realize that when we go from 0 to 100, we've got 101 values that are integer values. So we can try doing this again. And instead of saying number of steps being 100, let's make the number of steps 101. There we go. Now it's nice even integers like before. And there are 101 values. Let's go take a look at this. This doesn't tell us how many values. In this case, 21 values. There's 1 to 100. There's the 1 to 100. And we have, oh, that's 1 to 100. Let's just see what happens when we do A equals square bracket 0 colon 100. And it's going to be rows. And it tells us there are 101 values. There we go. This accomplishes the same thing. This gives us steps all the integers. This does too. It'll give you the same result. All the integers from 0 to 100. Okay, that's creating a vector. Next topic, ladies and gentlemen, creating 2 by 2 matrices or 3 by 3, n by n matrices. So get rid of the old stuff and go A equals square bracket. Square bracket starts and ends a matrix or a list or a vector. So I want to do a matrix 1, comma 2, comma 3. Comma will give you the next row over. So, excuse me, not next row, next column. So the vector will come out 1, and then 2, and then 3, or the matrix, I should say, will come out 1, 2, 3 on the top row. Colon tells MATLAB to go to the next row. 3, 4, comma 5, 6, semicolon. Oh boy. Semicolon means go to the next row. Semicolon means go to the next row. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Square bracket to end it. And we have a 3 by 3 matrix, and I did not put my commas between my 7s, 8s, and 9s. There, got a comma between them now. So this creates a square matrix, and we can do lots of things with that. It doesn't have to be square, it can be any kind of rectangular matrix. So let's create another matrix. B equals square bracket 3, 2, 1, 3, comma 2, comma 1, semicolon 6, comma 5, comma 4, semicolon 9, comma 8, comma 7, and then end it with the closed brackets. There we go. So we get a different matrix, and we can try subtracting one. We can add, subtract, multiply, and divide matrices. We'll see how that works. A plus B. A plus B. Element in the first column, first row is added to the element in the first column, second row of B. So that should give us 4 in the first column, first row. Second column, first row of the two matrices they're both 2, so that would give us 4. So the first, they're both 4. 1 plus 3 is 4. 2 plus 2 is 4. 3 plus 1 is 4. Why did I do that? This is going to give us 10. 4 plus 6 is 10. 5 plus 5 is 10. 6 plus 4 is 10. Second row is going to be 10 of the sum of this sum. So let's see what happens. We got it. Last one, 7 plus 9 is 16. So addition is strictly element-wise. Let's take a look at B minus A. 3 minus 1 is 2. 6 minus 4 is 2, and so forth.